I think we're good.
Yeah, let's see. Oh, I think we're live. So, hi everyone. Thanks for joining us on our live webinar today. If you haven't subscribed to our channel yet, please do it to help us. So I really appreciate who can do it. It's our first webinar in English. I hope it's the first of many to come. I hope I don't screw up and you guys are able to understand everything. But if you cannot understand, please forgive me because I'm not really practicing every day. So let's hope it's a good talk for everyone. And during the webinar today, of course, you're more than welcome to ask whatever questions you have, and we'll try to discuss them within the time. And if you, by any chance, have any questions afterwards, you want to follow up with Kwaja, Daniela, or even myself, feel free to reach out to us as well, and we're going to be really happy to guide you in whatever subject we can. So before everything more specific, I would like, please, Kwaja and Daniela, to ask you to introduce yourselves, telling a little bit about your background and career, telling how you got to this kind of subject, mission critical applications, how you have been applying that in your products, and it's a pleasure having you. First of all, thanks a lot for making the time to join us, and you're more than welcome to share your experience with us today.
All right. My name is Kwaja. I started my career working on cameras on board the Mars rovers that we were shipping to space, taking pictures, and went up the stack to working on software and data processing pipelines. And this was in the mid-2000s. I got tired of ordering machines from traditional infrastructure providers and waiting for them to show up. So I became one of the earliest customers of AWS. And that was, again, mid-2000s. There wasn't a lot of services back then, but I learned a lot and got to influence the AWS product roadmap and presented a fair amount of the innovation that we had done, including a keynote at KubeCon Brazil, some courses in Sao Paulo that I taught with the KLM team, and a keynote at Agile Brazil as well, just to talk about some of the practices involved in promoting innovation and the pace of innovation. In 2013, I joined Amazon full-time, and there I ran DynamoDB, which is a very large-scale, mission-critical NoSQL database, runs 100 million plus transactions a second at any given time for peak capacity for customers. And if Dynamo is down, the whole world suffers in many ways. So the stakes are really, really high in the way we operate the business, but also because the market is evolving so readily and there's so many NoSQL options out there, the pace of innovation on Dynamo was just as critical. So I learned a lot about how to maintain the pace of innovation while continuing to insist on the highest standards. And that Dynamo team is where Daniela and I got to work together as well. So I'll pass it on to Daniela.
Yeah, thanks, Kwaja. So I'll pick it up from the DynamoDB days. I was an early engineer when the team was quite a bit smaller than it is now. When Kwaja talks about the mission critical nature of DynamoDB, I think there was a few, unfortunately, big outages for Dynamo where it did, in fact, take, literally people on Twitter were saying half the internet is down because DynamoDB is down. It's tier 0 and internal to AWS as well. A lot of other AWS services will be down as soon as Dynamo is down because it's a source of truth for a lot of data that's stored on the internal services. From there, I joined a startup that's grown over the years, but when I joined, they were a small startup in San Francisco. They're called Lightstep. They specialize in observability. So more and more, I think there's needs for better visibility into modern microservice architectures. Distributed systems can be very complex and certainly very complex to observe and to get good data on through debugging. So I spent a bunch of time in that domain, sort of learning about the different ways to gain insight into a distributed system. And then from there, Kwaja and I both felt that what we're currently sort of working in, the field of high performance, mission critical caching, was an area that could sort of benefit from more sort of focused innovation. So that's what led us to work on Momento, which is a serverless, highly performant, completely serverless cache.
Oh, that's awesome. Thank you. And I like to tell our audience, not many people are aware of what's observability and all the implications, but I like to explain that we could call observability like the monitoring for the cloud age, in which you have a moving target, you don't have anything static that's kind of easy to be monitoring, and then you need to apply different techniques, and it's a totally different problem. And usually, I mean, sadly, most people only start caring about monitoring observability when they start having production issues. So it's much easier when you prepare your environment, your applications to be monitored properly, but we can talk more about that along the talk. So we have even introduced a little bit the discussion, but since we have started talking about the Mars rovers and DynamoDB and everything that has such a critical impact, I'd like you to help put things in perspective and provide some content to our audience, ask you to define what exactly are mission critical applications. I mean, what can we really call like a mission critical application? I mean, what's the level of impact? I mean, what occurs if a given service is down? Just for us to have a better, point of view of what's the level of impact. And you mentioned DynamoDB. If you could elaborate a little bit more, it would be helpful for our audience to be able to follow up.
Yeah, so there's an extreme of mission criticalness when you're sending things to space, really expensive missions, especially if humans are involved, where you just can't afford for things to fail. And every minute that the thing is failing is, either somebody's life is at risk, or you're wasting valuable time of the limited time that you have for a spacecraft. On the other hand, on the DynamoDB side, there's a service that powers the control plane for much of AWS. Lots of other customers are using it. And if this goes down, a bunch of customers have taken underlying dependencies on Dynamo, so they get impacted. And it's that one, the space and Dynamo, where it's a little easier to call that mission critical. But I have a slightly more sensational description of mission critical. To me, a mission critical application is something that really impacts customers' livelihood and continuity of their day-to-day when the service is impacted. So, our lives are evolving. We sit by the applications that we use. We are, moving towards a digital age. And if I can't open my garage from my phone, that's customer impacting to me. And the folks that are building the awesome IoT devices that are powering my garage, whether they know it or not, they're building a mission critical application. So if you have an application that will meaningfully impact the customers in the most subtlest of ways, it's automatically mission critical. The other piece is that it's a lot easier to treat your application as mission critical from the very beginning than to become mission critical later. It's just, to me, like getting an A in mission critical operability is a lot easier than aiming for like a B- or a C, because once you let go of that bar, things just kind of fall apart. So that's my sensational definition of mission critical. Daniela, you would have anything to add to it?
Yeah, the only thing I'll add is that I think it sounds like a very technical and engineering term. I think it's actually more impact on the business than you would think, right? Because mission criticalness wins businesses, right? If in the US, if Lyft is down, I'm sorry, Lyft, but just hypothetical example, if Lyft is down, it's going to use Uber, right? As a consumer. Right. So it's like little things like that. It sort of has direct impact on the business. And I just think that aiming for like a B+ on mission criticalness is going to have a direct revenue impact, or however you measure this business, the success of the business. This is not just technical.
Yeah, definitely. I was talking to my wife recently, and she's not technical, she's an obstetrician, and she was complaining that the entire agenda I mean, couples who went to have their exams, they were like delayed for like a couple hours just because some whatever system it was there, it was not running. And then you have, I mean, a lot of people actually impacted, I mean, with a lot of anxiety because, I mean, a pregnant couple willing to have their baby exams and they fail to do that. I mean, sometimes they can't do and they need to go back another day simply because one application was down. And sometimes it's even the most basic ones, like something that controls like the schedule or even like this, where you input your comments on the exam. So a lot of daily issues happen due to lack of monitoring, lack of reliability, and what we need to have in perspective is if your customer does not trust your application, does not trust your service, you definitely gonna lose customers to some other company who treats them better. So it's definitely really critical to companies. And Daniela, you have a really good experience with distributed tracing, which is one of the key components that we have right now. It's, if I'm not mistaken, the most recent one, I mean, comparing to logging and to monitoring. And if you could like explain a little bit more about the role of tracing in this observability stack. I mean, we have now a lot of applications, a lot of services. It's a much more complex architecture. Can you explain how tracing plays an important role in this observability context?
Yeah, of course. Although I think Bruno, you're also an expert from your work on Alvin Works. But my own perspective is that tracing is not to be put sort of to juxtapose against metrics or logs, which are traditional tools of observability that everyone here should be already familiar with. It's really a combination of them, right? It's taking on a new format. Because all it is trying to pull together the different points of observability. For logs, oftentimes it's component based. So if you have a front end and a back end, you have logs on both. And all the trace is trying to do is trying to correlate it with each other and then look at it from the transaction or the customer's perspective. So it's sort of request tracing where you follow the life of a request through the system. So I think it's really not that you choose tracing or metrics or logs. It's sort of very intertwined. And I believe that over time, we're going to, as the idea of having traces gets more ubiquitous, is going to become just as easy to grasp as a new concept. Right now, it's sometimes foreign to people, but really it's just a different way of looking at metrics and logs in a more holistic end-to-end way. And the reason I think is promising is because in my very simple example, you have front end and back end, and that is the simplest unit of a complete system. Sometimes you don't even need a back end, so maybe one component. In reality, the number of components are literally exploding in like actual systems. I've seen customers that work with thousands of components, like one request will go through thousands. It's kind of ridiculous when you think about it, but unfortunately, that's what's needed. And that's how the modern system sometimes just evolve. When you have 1,000, it becomes very onerous to track 1,000 components. So sometimes you need to be able to look at it from the request perspective. And I think that's how tracing has been very helpful and has gained momentum in recent sort of years is people start to look at it as a way to really get rid of the noise in a very large system and look at it on a singular transactional basis.
I think as the world evolves more towards microservices and away from monoliths, each microservice is going to get, the deployments and so forth independently. So there's just a lot more entropy in the system, and tracing just becomes more and more critical as a result of that entropy and the pace of innovation that microservices bring as well.
Yeah, definitely. And what I have been seeing, I mean, most companies, at least in my experience with consulting and now with the platform, they don't really know what are the dependencies for each one of their applications. They might have a good notion of maybe the main ones, like your transactional database, your caching service, maybe your messaging queue, but typically they have much more dependencies they don't even control. Let's say we have worked with a lot of e-commerce in the past, and then you go help them in the Black Friday, and they have inserted a lot of different tags from partners via Google Tag Manager. They don't have a clue what's actually running in their applications because, I mean, this kind of autonomy, self-service ability to deploy new components and plug some new features makes you pretty much unable to track everything. And I believe this might be like my opinion, but I think it has happened in such a way. When we came from like the on-premises data centers, and we went, we had like I2 configuration management, the CMDBs, and all that kind of control. It was a much more static environment. We went to the public cloud, and we have now self-service abilities. We can pretty much do everything without asking to a centralized team very, very often. And then we lost track of those dependencies. We don't know anymore everything which is running to support our product. So tracing kind of lets you do one of the hardest parts, which is pretty much this correlation. I mean, you identify that maybe a given service which has increased latencies is impacting another service which you might not even know it had a direct impact on. So it's kind of pretty interesting. And now going to the topic of failure and fault tolerance, it's very often that we know that in cloud platforms, everything fails all the time. I mean, you can have a virtual machine failing in the stores. I mean, you have a lot of underlying noise and problems, and you need to filter out for all those noise and actually identify what's impacting your customers. So how in such a distributed architecture and a lot of moving parts, how you treat this failure and fault tolerance to make sure that your customer is not receiving any impact, even if you have some failing systems underneath. So how you treat that usually?
To me, you start with the assumption that everything is going to fail. There's an awesome blog by the Amazon CTO Werner Vogels around how everything fails all the time, and those words just resonate with us. And that doesn't mean that it shouldn't be misinterpreted that the quality bar isn't there. It's just shit happens. That's just reality. And what happens is, as your application gets popular, your infrastructure is going to get bigger. And there's just laws of large numbers where, even if you have a 1% annualized failure rate, which is pretty low for infrastructure, when you're running 1,000 nodes, you're going to get nodes that are going to fail every few days, and you have to be able to detect it. And the other part is that failure is never black and white. It's very rare. The black and white failures where a node just dies and commits suicides, and goes away, those are the easiest to deal with. The kinds of problems that really hit people is if you have, like, let's say 1,000 node app server fleet, and 2 of them are just suddenly just taking an extra 2 seconds to respond, and that's causing back pressure, that's causing, request a timeout, and the entirety of the timeouts are coming from those 2 bad nodes. This is a common scenario that we have seen from running very large fleets, where not this particular thing, but like this notion of like a couple of nodes having bad code, being slow, having misconfigured, setting the wrong responses. So instrumentation with that paranoia. So the paranoia that everything's going to fail leads to the action of instrumenting the hell out of your system so that you can rapidly diagnose what went wrong, and then you can take action on what it is that went wrong. So you start with the assumption everything's going to fail, you instrument, and then you have run books to detect and mitigate the specific situations.
Yeah, that's awesome. Yeah, something that we tell often our customers and everyone that's talking to us is that typically your systems, they tend to degrade before they actually go down, and it's much better usually finding out a few minutes earlier that, oh, things are not going well. I mean, we have increased error rates here, we have increased latencies, something doesn't smell good. Let's check what it is. Then finding out quickly after it already happened. So pretty much all the golden signals, SRE golden signals help a lot there, are pretty important for that. If we can have the proper signals instrumented and we can do some anomaly detection, we can find out hopefully a few minutes before, and then we can have a valuable time for us to prevent the biggest impact. So that's pretty interesting. And while we have all those applications and we have a lot of automation, we tend to apply, I mean, continuous delivery, continuous deployment to many of those applications and services. And simply, there's a lot of movements. I mean, a lot of things move all the time. How can you, in such mission critical applications, keep track of what's working, what's not, and I mean, keep the level of velocity? I mean, it's a really very fast pace, and still manage to keep track that everything is working smoothly. So how you can go really fast without breaking things?
I think it starts with the instrumentation again. You got to make sure that all of your underlying dependencies are instrumented. You got to make sure that you're explicitly thinking about what are the leading indicators that are going to cause problems, and you have instrumentation and alarms set on them. And once you have that, like you also recognize with your paranoia that what's most likely to break is your own deployments. And especially with continuous deployments, like most of your outages, including outages for your underlying dependencies, are going to be because somebody did a deployment somewhere. So deployments are like these very turbulent times. Usually they're fine, but you know how when the airplane is taking off at the airport, you go there, you're flying, they tell you turn off your phones, like right when the plane is taking off and right when the plane is landing. That's like a deployment time, right? So you gotta be ultra cautious during that time. And what that means is, doesn't mean that you have to sit there and wash the dashboard every time you're doing a deployment, especially if it's continuous deployment, but it means that the instrumentation and the alarming and the canaries that you have put in place are doing that watching on your behalf. And they can tell you as soon as something breaks. And whenever I got a page to be to drive a call for an operational issue that was happening within AWS, you know, there was two questions I would ask. The first one is, what's the customer impact? Just to understand the gravity of the situation. And the second one is there something that we deployed recently? And if the answer to that is yes, we immediately, no questions asked, you roll back the deployment. And there's a famous saying inside of Amazon, which is roll back first, ask questions later. We have learned over and over and over again that deployments that, you know, in the heat of the moment, the engineers are looking at it and we're saying, nope, that deployment couldn't have caused this particular thing by any means whatsoever. There are things that like make sense in retrospect, and it is not worth continuing to put the customer impact in jeopardy by not doing the rollback. So the rollback is a really, really critical feature that you cannot have continuous deployment without. So instrumentation and the ability to roll back will allow you to maintain that continuous deployment without being you know, slowed down necessarily. And there's a whole bunch of other things that we'll talk about in a bit in terms of how you maintain that pace of innovation. But that's just, this is what we would do to make continuous deployment actually be successful.
Yeah, that's awesome. And something you mentioned that I totally agree. I mean, kept seeing like, I mean, people trying to monitor production environments. They instrument, I mean, whatever is the application server, maybe the dependencies and everything, and totally ignoring the product development workflow. And what we do, I mean, one of the first things we did on our platform, we have an observability platform as well, is I want to keep track of whatever is happening from source control to the instant in production. I want to know when you had deployment, whenever you had a hot fix or a rollback, and I want to calculate those data metrics for you to understand, oh, how frequent is are deployments for each one of the applications, how often do they fail? Because much more common than, I mean, Amazon Web Services failing, which happens like a couple times a year, maybe, several times, but it's much more common that we have deployed new code which wasn't properly tested, wasn't maybe fully integrated, fully load tested, and that new deployment caused the problem. Then, I mean, we might be facing a massive outage from the cloud provider. It's much more common that we did the mistakes, and having this ability of correlate, oh, there's been a recent deploy here. I'm not so sure what's the impact, but it might have caused it. It's much more, I believe, much more clever doing the rollback and trying to revert back to the stable state, and then actually, of course, you can have your post-mortem and root cause analysis with much more time after the customer impact has been solved. So I totally agree with that, and I believe, I mean, modern monitoring observability needs to gather all the data sources you can have that can correlate for a given instant. Maybe you have some NPM repositories that you change some of the libraries. And I mean, it's very hard for you to keep track of everything you're using and what might have caused. I mean, we have many components to depend upon. So after definitely you revert back to the stable state, resume serving your customers properly, it's much easier for you with all the time you need to understand what actually caused, and maybe getting the fix for the next release without any customer pressure. So I totally agree with that. And talking about this preparation before you put some new features in production or maybe a new product launch, I really like the approach of the Google SRE of using the launch coordination checklist. And Kwaja told me you guys used a similar model, which was called like operational readiness or something like that. Could you explain how exactly that worked? I mean, what's the story, how you managed to use that to prepare better for production releases and everything which is involved with putting software into production?
Yeah, so operational readiness review is a term that originated, at least before Amazon, it originated at NASA, where it was referred to for measuring the effectiveness of a spacecraft or a launch vehicle, where we would go through a checklist and say, are we ready to operate this thing and deploy it? And a lot of the words in fullness of time in the SRE world came from that landscape in general. But are we ready to deploy this rocket or to send the spacecraft and start operating it? And what happened was there would be a set of items that would get identified, and they would get written up in some cases at NASA before even any work started on the mission. Like they would start getting written right around the time when you're writing the PRDs, the product requirement docs, and they served as a mechanism to keep the teams accountable on whether or not you're ready to do the liftoff and whatnot. This term got borrowed into AWS from NASA as a mechanism to assess whether a service is ready for launch and whether a new feature is ready for launch. And one way to interpret the operational readiness review is that it seems like a set of blockers or like things that can go wrong and we should just stop the service without it. And that's not what it is at all. The operational readiness review is a mechanism by which the service owners and the product managers identify the critical risks to the service. And they put all of that down in paper, because a lot of times if you have 5 different people on the team, they each have 5 different set of risks that they are thinking about. But this explicit motion of writing it all down on paper, prioritizing the risks, and then making a call on which risks are worth taking and which risks we can fast follow with, is a really worthwhile exercise. So it's not an idea to prevent you from taking risks, but it's an idea to help you take smart risks and to do a balanced and pragmatic assessment of whether or not you're ready to launch. And then what do you need to do immediately after launch for this product to be successful?
Yeah, that's awesome. And we have talked, I mean, internally for people who are following us right now, we're going to provide you a template of operational readiness documents so that you can start applying that to your products and have a better view of availability and what can go wrong and how to treat that. It's interesting because I mean I really like the launch checklist, but they don't have any ready to use template. They simply list a lot of stuff. I mean, it's really valuable, but not really actionable. I mean, you cannot simply pick one of those templates and apply. And I think for companies willing to start doing that in a better preparation way, it's helpful to have something a little bit more baked in. I mean, something ready for them to start. I think it's really helpful.
I think I like to think of ORR docs as they're more intimate than like, I think they're really hard to generalize because to me, it is a list of risks that the team is thinking about and is concerned with and writing them out down on paper. Everybody will do it differently. And that's okay. It's like your resume, right? Like there isn't like a universal template for a resume. There's lots of examples and there's like lots of templates you can use, but you really got to pick the one that speaks to you. And like resumes, you can iterate on this. So the most important thing on the operational readiness templates that you build for your company is that you continue iterating and you keep improving it over time. And each launch is going to have a different set of criteria for, like if you're launching a website, that is going to be very different than if you're launching a mobile app on iOS only versus an app that you're launching and it has a website and it's supporting, you know, multiple types of phones and so forth. So it's really difficult to, you know, kind of templatize this, in my opinion. I think you just have to do the motion of, you know, identifying your core risks and the business impact of that risk manifesting and what mitigations can you take, and then a conclusion on whether this is a risk worth blocking the launch on.
Yeah, definitely. Yeah, I think in some cases, I mean, if you pick like the well-architected frameworks, I mean, there's no generic architecture for whatever product you're building, but you can have some good recommendations for like an e-commerce or maybe for a digital bank. Or I mean, there are some specific scenarios which are good to have some ideas. And I think it's pretty much providing ideas and people can improve that internally. But one thing I recently saw, a really mature company, really unicorn and totally mature, really good engineering team. They had an issue in production because one of their new products had a external dependency, which had in production not a great rate limit from the partner. And they put into production, then things started to fail, and it was something outside of their core perimeter. It was something outside, but something that required configuration for production. So sometimes having those templates and the questions that an experienced team would ask to help people who hasn't maybe put a mission critical application to production, I think it's helpful because we can give ideas, and if it's not relevant for that use case, okay, you can ignore it and move forward. But having those questions and most common scenarios, it's really good for people to improve preparing themselves for new product launch. So it's really interesting. And thinking about, I mean, digital products and competition, I mean, Amazon Web Services, for instance, has some really strong competitors, and everyone right now has fierce competitors. How you manage to deliver? Oh, sorry about the noise. The kids are screaming right now. It's always that time when it's their dinner. So
it's a beautiful sound. It's a beautiful sound. We always enjoy that when we hear sounds of babies in the company or kids in the company. We always celebrate.
Yeah, we gotta be fault tolerant and ignore the noise, but that's okay. So typically we always have kind of some pressure in our product roadmap that, I mean, we need to be shipping features and a lot of things that hopefully are gonna drive more customers to use our products. And we have all those requirements which are not exactly something the customer wants, I mean, but they expect your service to be working and be reliable. So how you can balance that? I mean, shipping really quickly, giving value for your customers while measuring all the risks and keeping track of everything that can go wrong. How to balance that?
I think it's balancing. You mean like just the pace of innovation and the errors that happen? Look, Google folks have a very interesting approach. They say you have an error budget, you have an outage budget for the year, and that budget is explicitly not zero, because the easiest way to aspire to have like 100% availability is to just don't change anything at all, right? Anytime you change something, you have meaningfully increased the risk. So you start by thinking about, well, how do I keep making changes faster, but really improve my ability to detect and mitigate any side effects that happen on that from those changes. So that's really, really important. So the instrumentation, the rollbacks, the trainings, all of that is really critical. The other piece is, like, as Danielle was mentioning in the beginning of the conversation, like, Dynamo is mission critical, AWS is mission critical. Doesn't mean AWS hasn't had, outages. Like, the more important thing is that anytime there are outages, that you learn from them, and not just from the really major outages, but every time there's like a spike in latency for 10 minutes, you have to have the operational rigor to be able to explain why. So some of the mechanisms that we use inside of AWS was a weekly dashboard review, where teams would get together and we would go through their dashboards. Each of the underlying dependencies are graphed. Each expected latency curve is graphed. Requests rates are graphed. Error rates are graphed. And every time there's a spike, the on-call has to explain what actually happened. And no service is perfect. No matter how rigorous that service is, you will always find things that we can be doing better. And if you don't do this, you will miss out on leading indicators that can prevent outages. So there's a whole lot of outages that have been prevented by this rigorous and regular review at a weekly cadence for every single service inside of AWS. And when we talk to people about it, it seems like a total waste of time to some people, where it's like, well, no, I got to be writing code. Why would I, take on this extra work? Because it's not just a presentation you have to prepare, but it is that preparation, and that helps you identify, the ghosts that are hidden in your service. And then lastly, when there is an outage, rather than just a spike, whenever there's a customer impact, Amazon has this really nice process. You can Google it. It's called correction of errors. And this is another reinforcing mechanism to make sure that we're learning from any customer impact whatsoever. So correction of error template just basically says, what was the customer impact, duration, how did you detect it? How could we have detected and mitigated this in half the time? And then there's this really interesting section, which is the 5 whys. And the 5 whys are important. You're just this promotes dive deep. So why did it fail? Why did we have error rates? Well, our database went down. Why did our database go down? Well, we, upgraded from Postgres, version X to version Y. Why didn't we have a mitigation plan? How did we test it? So there's a whole lot of just like drilling at the 5 level as to what actually happened, to be able to explain. Then there's sections around where are the graphs that demonstrate the customer impact. If those graphs don't exist, well, we got to go build those graphs. And then the last section of this is really important. It's actions. What are you going to do to fix this so it doesn't happen again? But it's not just a list of actions. It's actions with dates and owners. And previously, in the early days of AWS, people used to promise the world. Every time there was an outage, there would be 100 actions on there, and people say, we're going to do this, we're going to do that. We're going to just, fix everything in the world with the service. And the problem is that when you take that many actions, it's easy to just say, yeah, I did, 10 or 20 really important things, but, the rest aren't done. What we started doing, middle of the way is we started saying, no, the actions you're taking, they're going to be tracked, and we're going to make sure that you complete them. And this forced the teams to not promise the world. It forced them to prioritize and only promise the things that are critical. And the way we forced it is there's a central tracker that has the actions with dates and owners. And if you change the date more than twice, your VP gets notified that, hey, this date has changed. If you cancel an action, your supervisor gets notified that, hey, this action that was promised has been canceled. And this was just a really transformative change where in fact, it prevented people from offering too many actions. But then when people saw the correction of errors, they knew that the plan that is being promised is actually one that the team is going to stand behind. And if the team doesn't stand behind it, we will go back and say, why not? So this virtuous circle is really, really critical to build that culture of availability across the organization.
Yeah, definitely. I mean, the sense of responsibility and ownership is really important. And definitely, I think, I mean, I can imagine the level of stress you get when you have a massive impact in Amazon Web Services. Should be like the world stops for a few minutes. And it's really nice to enforce. I mean, I like to stimulate people doing blameless postmortem, because it's not really one person's failures. I mean, the system and the culture, the process didn't prevent that problem from occurring, and then you need to learn as a group and not be, I mean, pointing fingers at people who maybe done something wrong, because you gotta have them learning and improving, and you gotta have that person creating value, I mean, from time to time, and that means taking some risks and learning when you do something that might have caused a problem. So that's important. I'm gonna respond to a couple questions that people asked on our chat, which were really interesting. One of them, and I'm an electronic engineer, so I can correlate to that, I mean, really well. I mean, when you have a given piece of hardware in place, like, let's say a rocket or maybe a Mars rover, it's not simply a piece of software that it can reproduce on everyone's machine and test it, I mean, 1,000 times. You have some conditions there, maybe the gravity in Mars or the moon or what. There are some conditions which might not be easy to have a proper environment for you to test. So how you treat, I mean, those components you control, which were actual pieces of hardware, it was not only software. How you make sure that you tested everything you need, and how to make sure even like the emulator or whatever system you have to reproduce some conditions that we might not have here, how you I mean, connect those components, I mean, the software that runs on that component and the conditions which might not be available here. I mean, in the Earth, we don't have Mars gravity, so a lot of things depend upon some maybe critical conditions, not trivial to test. So how it worked with a mix of hardware and software components?
Yeah, the Mars rover example is apt because when the Curiosity and the Perseverance rovers, specifically in Curiosity rover, it's like a 1-ton rover, it's the size of a car. It landed on the planet or with a, on its wheels with a parachute, right? And that condition had never been tested. It's untestable on Earth because Mars's gravity is different. And also the atmosphere of Mars is 100 times thinner than Earth's atmosphere. So your parachute is going to behave very differently on Mars than it is on Earth. So it is completely untestable. Now, this particular phenomenon is not unique to Mars, because what happens is anybody who's telling you that they have 100% test coverage is lying. Nobody has 100% test coverage. And because no matter how much you emphasize, comprehensiveness on your testing, you will miss use cases. You will miss corner cases, and you will miss things that just don't get exposed until, the behavior of the customer kind of shows up, because customers will do things that you may never anticipate. And that might put your service in, like you might have degenerate flows that put your service in pain. So what you have to do is you have to start with the assumption that your testing is not 100% complete. And you have to do this anyway if you want to maintain a fast pace of velocity. It doesn't mean you don't test. It just means that you assume that once in a while things will pass through. And on Earth, we have something that we can't do on Mars, or when you are parachuting down, you can't roll back. If you're, if you jumped off a plane with a parachute and there's a hole in it, well, too bad. Maybe a backup parachute, but you can't roll back and go back onto the airplane. But with deployments, you can roll back most of the time, especially if you're thoughtful about it. So you just assume that the full conditions are not tested, and you have a rollback strategy to get back to the stable state. And you just move forward that way. And then you can learn, if you have the instrumentation, you have the ability to reproduce what actually happened in production that your test cases didn't cover. And now, if you have that culture of availability, one of the things you're going to do is to add that test case so that you are actually expecting it you're actually catching that specific test case in the future.
Yeah, awesome. And I'll pick the second question from our audience because it's really connected to the next one I was about to ask, which is, I mean, you have in Amazon Web Services, even at Momento, which is a new company, but really mature, I mean, a dream team, I mean, a really good team of engineers. And many companies, they have a small team, maybe doing something critical, but they don't have all the competencies, all the resources they would like. What kind of advice can you give to a company that maybe is developing something critical, maybe it's still a small startup, who doesn't have maybe all the engineers they would like? How can they move forward with a good pace and good level of maturity when they don't have everything they want? I mean, can they reduce complexity applying some techniques? What they can do to build something which is really reliable, really good for their customers, when they have such a small team which doesn't have, all the knowledge and all the engineering experience that a more senior team would have? What could you recommend to those teams?
I was going to say one thing when I saw the question on YouTube. Congratulations. You're in a really good place to start building that culture now, because like Kwaja said, if you're already running, multiple systems and you have an existing engineering culture, it's very difficult, not impossible, but very difficult to instill that culture in later. And then you have to go back and do a whole bunch of work because it might fundamentally impact the design of your system. So I think just like start that education while you're small and while you're young. And you'd be surprised, like I think we're making it sound like a list of work that you have to go do, but really it permeates every little bit of decision that you're doing as you're developing. Sometimes it's way easier to incorporate that kind of mindset as you're writing new code and identifying trade-offs as you're like writing the code. Because of that awareness, you can document, you can make certain decisions differently to say, hey, this is a way that I can write my code such that it's easier to instrument and it's easier to debug later. It sounds obvious when I say it now, but like that culture has to exist in addition to just moving fast and getting it working, right? Like it has to be combined, and both are not mutually exclusive. They can exist at the same time. People can write fast code that's still available and mission sort of meets the mission critical bar. So I think it's actually really good to start with a small team and to kind of build that in and build that culture of reviewing code in a way where you're asking these right questions, right? And sometimes having that list, I think, launch readiness template or our operational readiness list, it's good because you're documenting, I am recognizing there's a risk here because of our velocity, and we are deliberately okay with taking the risk at the moment, right? So you're not 100% checked off on the entire list, and that is okay, because at least later on when something happens or when someone else wants to do things a certain way, you can point to that list and say, hey, no, we agreed on a decision, and then you can decide to revisit that or not. But all these conversations are way easier to have actually when you're small.
Yeah, that's awesome. Something I would like to complement that, each team might have a different level of maturity, and they might be proficient maybe at software development, not really on infrastructure. And currently in the cloud providers and even some platform as a service components, they can abstract away some of the complexity that you might have to manage that. If you, maybe let's speak for instance, if you are building everything on top of virtual machines in which you need to manage the operating system, all the patches and everything that runs there, it's really a lot of trouble, and you need to be really mature about doing everything underneath. Maybe if you choose to be using some building blocks, which are maybe some serverless components, or maybe some managed container service, or maybe managed Kafka queues. I mean, there are several options right now that can abstract away much of the complexity that you could be having if you choose well. I mean, what's really a good decision for your team? And there's no general rule, but it's pretty much choosing a good, reliable option for the core competencies your team has seems to be a good idea, because then you can opt to dive in and to improve where you can really create value, and when you can really create, like probably a small team wouldn't create any value managing by hand a Postgres database. They can totally go with Aurora Postgres and abstract everything they don't need to be doing. So I think a key moment in the product, the team's life, is choosing what are their building blocks and trying to use the least complex architecture as possible. Do the simplest thing that might possibly work. And my friend Byros is there in the chat. He used to tell me like 15 years ago, and it's still true. I mean, do the simplest thing that could possibly work, and then keep improving on top of that. And deliberately choosing the less complex architecture that solves the problem, it's a good idea for a small team, in my opinion. I think it's better to do that way. And now going to a more, team and culture question. I mean, we talked about some really complex and mission critical scenarios, and some stuff that do require some awesome engineers, and we from time to time need to be onboarding new people in our teams, junior engineers that might not have all the skills. How you do that? I mean, how you are able to pick maybe a person who's the first or second year in their careers, and they have a pretty good potential but not the experience yet. How do you insert those new team members in the team in such a way that they can create value while not bringing such a great risk of breaking something in production? How do you suggest people do that? I mean, onboarding new junior team members in your team.
There's a few things you can do. Number one is being a shadow on call is really helpful. I can tell you, you will never learn more about the service architecture until you see the service fail. So being on call is one of the best ways to onboard a complex system. And if you're worried about the person potentially breaking something, then have them shadow a more senior engineer. Have them watch what the senior engineer is doing, and they will learn so much in doing that. The second piece is that, again, you have to have the controls in place where they can't mess things up. At Amazon, one of the rules that we put in place was this 2-person rule. Anytime you're doing something manual, and this, by the way, came after a bunch of outages that have been caused by manual changes. But if you're making a manual change, you have to have a second person review and approve. And the way you do this is you just create a process by which, another like brand new employee isn't approving a change being made by a different brand new employee. And then lastly, we were talking about blameless postmortems earlier. Amazon has this, or used to have this, really interesting leadership principle around being vocally self-critical. And that principle was actually pretty cute the way it said it. It said, we don't pretend our body odors smell of perfume, meaning that we vocalize when things go wrong, and we create a culture of blamelessness in the process. So if a manager sits there and says, hey, I had that outage because that junior engineer over there did this manual change, it's not the junior engineer's fault that they made that change. It's really the manager's fault for not creating an ecosystem where that change could have been prevented. So having that ownership and inability and avoiding the blame on individuals, and then giving them the right shadowing opportunities with the controls in place to minimize the risk of them causing a damage is the best way, in my opinion, to onboard and make the best of the high potential folks that have just started on your teams.
Yeah, that's really nice. I mean, I haven't thought of the on-call routines, but that's something really clever. Although I might think it's not as easy as in the past when now you have everyone remotely from home. Maybe it's, I think it's one of the hardest things in this distributed team scenario, onboarding junior engineers and preparing the field for them to create value when everyone is remote. It's harder for you to realize when they are not really confident about something. Or I mean, I tend to think that mentoring is one of the things that when you can have several synchronous and if possible in-person meetings is something that becomes easier. But we need to find ways to manage that, because the distributed team and asynchronous way of communicating, it's definitely here to stay. So we need to find ways to treat that.
I think it might improve it in some cases, because you can, like one thing I didn't mention is runbooks, right? Like having runbooks and then being able to just hand the thing over to the junior engineer and say, hey, go run through this runbook. And then if you have that culture, that of virtuous circle and the culture availability, you might realize that, hey, this runbook is unclear. And then you go edit the runbook, or you ask the person to go change the runbook now that they have learned how to do it. So there's lots of really interesting things that you can do. We started as a remote only company, and we still are. And that, I think, helped us build a lot of good practices around documentation and runbooks to help ensure that all our employees are onboarded appropriately.
Yeah, definitely runbooks are really, really good. And I mean, it's something that it can really be reproduced and even be exercised and gamified. I mean, we were partners with AWS in my former company, and they had run here several game days, as they call, which is like introducing failures in given components, and you need to figure out what's happening. That's really an awesome exercise for you to improve your troubleshooting techniques and figuring out more about what can go wrong and how to treat that. There's also the Netflix Chaos Monkey components. I mean, there are several ways to treat. Although I must say, at least here in Brazil, I find it really, really rare to see any of those techniques in place. And it's much more going production and then learning production than, I mean, preparing with as much care as you guys described. But that's definitely a good recommendation when things become more critical. When companies get more mature, they have some good runbooks and techniques in place to manage all those risks and get their products more reliable for their customers. So that's awesome. And now shifting a little bit to what you guys are doing right now. I mean, you have all this experience building and operating distribution system and architectures. You really have some valuable advice for many companies to follow. Could you explain a little bit of what you guys are doing at Momento, and what's the problem you guys chose to solve? I mean, you mentioned, I mean, the problems about caching, everything that could fail. How you guys are actually helping companies design such mission critical and efficient systems right now? What's like the mission for Momento right now?
So this was actually inspired by our previous experiences working as application developers. I think if there's one thing to take away from what we're trying to do is we're trying to enable applications to be developed faster. We want to help product velocity. At the end of the day, it's about helping other people's businesses move faster by taking on what should not be something that wastes their time, right? Not something that they should spend time on. Specifically, that is optimizing cache performance, deciding how to shard your data across a distributed cache, deciding how to fail over, replications, or how to designing for highly available cached items. Usually the reason you want a cache is that you want the best performance. If you degrade that, or if it goes out, it generally has a very, very severe impact on your business. And at the same time, that's not something that we want our customers to be constantly worried about, because they're not a caching company. They probably have very critical business logic that they need to work on in order to move their product forward and accelerate them. So I think essentially the problem that we're solving at Momento is that we want to make it easier for everybody else to move their business, to accelerate their business faster.
Yeah, that's nice. And something why you mentioned that gave me some insights is a lot of companies, they might not have a clear view that they have a caching issue. Maybe the cache isn't really the issue, but they figure out that they are struggling with maybe some cloud costs which are higher than expected. Maybe their transactional database is failing due to some massive load. Then if you have another tool which can improve that, I mean, can make your cloud costs go down, make your systems more available, and you take away that complexity of putting that components in the architecture, then it becomes much easier. So typically, how would companies, I mean, when you talk to customers, how they realize that they might have a caching problem? Is it maybe the cloud costs, maybe uh, some service uptime which might not be so good? How will you identify, oh, there might be a great caching problem here? Because I think most companies are not really aware that they might have a caching issue, and maybe if they don't even know they have that problem, maybe the process of figuring out and then improving might be longer than they would like to happen.
Daniela has this really profound saying that it's always too early or too late to start caching. So when you're building the system, you're like, well, let me get it working and then I'll optimize. But the reality is that it's today, caching is just too frictionful to get started. You have to provision nodes, you have to decide how many clusters, the instance types. It takes forever. You have to plumb things into via your CDKs and CloudFormations and so forth. And what we really tried to do is to make it ridiculously simple. So the way Momento works is it's a cache that is ready in under a second and can hit millions of TPS without you doing any work at all. And it's zero config, built for high availability, high performance, without you having to worry about large scale distributed systems details. It lets you focus on cache hit rates and your tail latencies, which is the only real thing that you should care about. So our vision is to make caching much more simpler and easier. And we have focus tested this. Like, we have learned that customers who don't know anything about the way our system works, they can install our software and have a production ready cache up and running in under 10 minutes. And which is, like a really good mark. And then once they have it, they can make hundreds of caches after that with a single API call. But the way people know that they have a caching problem, if you're building an interactive application, the consumer demand for interactivity is going up. So if you want to maintain interactivity in your application and get customers to get the data faster, caching helps a lot. And in-region caching sometimes can help a lot more than just using a CDN, because if your queries are standing behind a database getting slow means that everybody is basically sitting there waiting. It helps with load. If your database is undergoing load and you keep having to increase the size of the database and increasing your database spend, it's time to do a cache. If you're having dynamic loads, it's time to have a cache. And then there's lots of applications. If you're using DynamoDB today, and you have a small working set and lots of reads that you're doing on the same items, using a cache can meaningfully improve your costs. And so using things like Momento or Elasticache or Redis can really help you reduce the load on the database, improve your performance and improve your availability at the end of the day. And our hope is just to make it so easy to get a production grade cache in your hands with the least amount of work.
Yeah, that's awesome. I have been studying a NoSQL system for maybe 12 years or something like that. And I really like to understand, the key trade-offs, the cap theorem, the acid versus base abstractions. There are a lot of trade-offs when you design such a system. And some of those services like Redis, Memcache, they are available for 10 years and probably with an outdated architecture. And having worked for so many years with such problems, what are the key innovations? Beside this kind of easy to use, zero config, way to integrate, what are the key innovations you brought to Momento? Knowing so much about the problem, how you guys are approaching it differently than the existing solutions. If you could explain a little bit for people that like me like to study NoSQL databases and availability as a whole, what are the key pieces that you put into the design of Momento that can make it so much more convenient than the existing solutions that have been available for like 12 years or even more, depending on the components?
I think it's the current state of the art is single node software that is then forced to run on multiple nodes, and that's just the way the current caching world works today. And this is fine. Like, it works for RDS, for instance, today. And if you compare RDS and Dynamo, there's a marked difference in how this works. The fundamental advantage that we bring is it's a completely serverless model. In the serverless world, you're not worrying about what the instance type is, the number of instances you need, the AZs you're in, the number of replicas. All of those complex configurations and knobs are taken away to give you a seamless, highly available, highly performant experience. Because the more knobs you have, the more likely you are to get something wrong. And modifying things is always tricky. So first and foremost, our experience is completely serverless. It's like the Dynamo or S3 style for caching, as opposed to, serverless. The problem that comes in with these server full instances is that as the number of nodes you have gets bigger, you start to increase the type of problems that you see. So you see things like load imbalances where, let's say you have 10 shards and one of them just happens to be busy. And the way auto-scaling works on these traditional systems is that you just double the capacity, and you don't need to add 10 more nodes. You just need to add one extra replica for the shard that's busy. But that doesn't happen today in today's caching. Auto-scaling just doubles the nodes and so forth. Or if you have a hot key, we automatically sample your keys. And if you are having a hot key, we automatically make more copies so we can give you a much better read throughput and even better performance on your most valuable keys. So behind the scenes, Momento is doing dynamic capacity management, it's doing heat management, and it's making sure that all of the things that would have caused your outages in your own self-managed caches are actually being taken care of in an intelligent manner. And then above that, we own end-to-end, including the client-side SDK. A lot of problems that we saw people having were just due to misconfigured clients. If you want to use Memcache or Redis today, lots of choices in the clients that you can download and use. There's lots of parameters. Some clients are much better than others. Some clients we saw had egregious availability risks, like untuned backoff strategies, or ability to make like lots and lots of connections, even when you can be using a connection pool and so forth. Momento owns the SDK. We built a proprietary, it's an open, but we built a custom protocol on top of gRPC to make caching really, really efficient. And all the SDKs from Momento have already been tuned to give you the ultimate performance. So you can do a lot more with just like, a very few number of connections to the service. So in a nutshell, it's a bunch of best practices baked in to give you the best end-to-end experience without any configuration at all, and help you get production scale and production availability without any of the work.
Yeah, that's awesome. I remember, I'm not a software developer anymore. I like to do something from time to time, but I'm not really updated. But it's really sad because I really like it. And I remember when we were like fine-tuning some configurations, fine-tuning the JVM, for instance, there were some counterintuitive tips, like, for instance, the most obvious solution would be increase the heap as much as you can, then you would have a gigantic space, but then the garbage collection would also take longer. So there are some in this kind of system engineering performance tuning, some counterintuitive stuff that maybe when you use, a misconfigured client or whatever fine tuning you need to understand a lot. Probably you're using worse solution than you could. So I can really correlate to what you just explained. So it's really interesting. And I mean, we are developing a really interesting platform, which is hopefully, I mean, gonna grow to 1,000 clients pretty soon. How can I start using Momento right now? I mean, are you guys available on AWS, GCP? Or how can I start using Momento if I want to test drive it for a given application and want to figure out how it can help us?
Go to gomomento.com and there's a try now button. You can go directly to our CLI, the command line interface. It's cli.gomomento.com. You can sign up for a authentication token just on the CLI itself. There's, completely self-service. We send you a token. You use that to create a cache over the CLI. You can do gets and sets over the CLI. And then when you're ready to really play, you can go to sdk.gomomento.com to download the SDKs in a language of your choice. So we're available in Python, in JavaScript, in Java, Go, Rust, .NET, whatever it is that, the flavor that you want, we can do it. And, and just send us feedback, right? Like we're in private beta right now. We haven't been broadly advertising this. So, but today you can go play with Momento without ever talking to a human. But as soon as you need any help, Danielle and I are here to be helpful.
Oh, that's awesome. Yeah, really nice to know, and we're definitely going to try it out at ElvenWorks and try to increase performance, improve performance, and have it much more available than it actually can be right now. So that's awesome. And Daniela, I would like to ask you, a final question. Sadly, we still have only a few women working in the technology market, especially in the engineering field. I mean, developing such distributed architectures. What kind of advice can you give to maybe a woman who's joining the technology market right now, who's willing to go up in the engineering field, especially in the leadership positions? What kind of advice could you share based on your pretty successful career? What was important for you? What kind of consideration maybe when choosing a company, choosing a team? How you can recommend new women enter the technology market and have a good career experience based on what you have lived? If you could please share.
Yeah, if I had enough time, I could do a separate talk just on this topic. It definitely comes up a lot. I'd love to. I wouldn't say that I'm successful. I definitely have experiences I'd love to share and discuss with the audience and anyone else out there with you as well. And Kwaja and I actually talk about this on a regular basis, but I'll try to distill it down to like maybe one thing, right? So that people can remember it. And I talk about confidence a lot. In fact, something that I struggled with earlier in my career as well, but nowadays I don't think about the fact that I'm a woman at work. It should be irrelevant, right? Like it's just not relevant to qualifications or skill set. It's my abilities and my experiences and what I'm able to contribute, what I'm able to bring to the table. But I think it somehow is still relevant because people, there's this confidence. It's you believe in yourself, put your feet on the ground, like, learn the right skills, understand, dive deep, like Kwaja said. We had a great conversation today about mission critical and availability and the different aspects of the complexities of distributed systems. We learned all of that through working on the ground, writing code, operating and debugging and struggling through very bad incidents and learning from that. And that all sort of comes from experience and helps build confidence over time. But one aspect of it is how you present yourself as well. And I think a lot of the time, maybe technical folks who are women think about the fact that they're women too much. So, and after all, there's also a very important aspect, which is that you do want to join a company that has that supportive culture, that do not constantly remind you that you're a woman, because it's irrelevant, like I said. So, I think Kwaja and I have built such a company already at Momento. We're actually 40% women and mostly engineers. Actually, if I can count myself as an engineer, all engineers, all the women at the company are currently engineers. And I think we're quite proud of that. And, we'd like that number to be higher than 40%. But I think it's a signal as people look around, look at their options. When I joined Lightstep, that was a signal for me as well. Having that representation and that kind of culture where we can be very supportive of each other, caring about, hiring across all kinds of diversities. So yeah, I think like choose the environment, your work environment carefully. And then once you're there, have confidence that you are a capable engineer that's capable of working on complex problems, and present yourself that way. So that would be my advice.
Yeah, that's awesome. I do think, a lot of that, the experience when joining a company is something the founders and the leaders, they should really try to create a culture that stimulates everyone to feel confident and feel embraced to try new stuff. And we had a webinar with it's also Daniela from C6 Bank, and she was telling that they connect to a lot of communities when they have like women who want to enjoy the technology market, and they connect a lot with communities, and they have a lot of onboarding tracks totally prepared to people to build trust and become confident about their skills in a low pressure way. So I think a lot of that and is really checking who's working with the company, feel represented. I think it's a key issue as well. It's really important. And identifying that the company is willing to do something, for everyone to feel safe. And I think it's trying to talk to people who maybe work at those companies to understand a little bit about the culture before joining. I think it's really relevant. And what I tend to believe it's, if the founders and the leaders, they did not have that in mind when they created a company and the culture became something tangible, I think it's much harder for you to create that kind of culture later, because it must be a vital part of the environment. So I totally agree with that. And we're trying at Elvenworks to have a lot of women and also people from other, kind of groups, underrepresented groups. But it's, something you gotta be really serious about doing, because sometimes some positions you might take longer to fill. It's not something that comes automatically, something you gotta put some energy to do. But I think it's really good to see the outcome that you get after you do that. It's really positive. So thanks for sharing that. And from my point of view, we could definitely offer some webinar talking about just that. How to build a culture of trust, how to onboard people from whatever backgrounds, whatever culture they might have, and they feel safe at work and they become really good professionals. So thanks a lot for sharing that. So that's all I had for today. And maybe if you guys want to share something with our audience, or maybe some next steps, maybe want to share something relevant, we are going to share the Momento website on the video description. We're going to also share that operation readiness template. If you have some more final advice or something you would like to share, please do. And I would like to thank a lot for our audience just for staying with us today. And thanks a lot for being here for this really interesting talk where I learned so much.
Yeah, thanks a lot, everybody. I think this was really fun. Thanks for organizing it, Bruno. And I think, my parting words are pretty simple. I think, I hope that we're working on something that we believe that is really valuable and can help, genuinely help other businesses, especially those of you that are building out your own technical systems and products. Please give us feedback. We're just getting started. We have high hopes and very ambitious goals for our product, but what makes it better are feedback along the way. So please reach out. Our contact information is on the website, gomomento.com. And yeah, please give us a try and let us know. It'll take, seriously, it'll take under 5 minutes. I think we clocked in around 2 minutes last time to get going.
And that's awesome. Thanks a lot, Daniela. Thanks, Roger. I don't know if you have any final. Oh, that's okay. Thanks a lot, guys, for making the time. And let's be together in future webinars. Follow us, and we will bring a lot of good engineering tracks and a lot of culture and people management content as well, because that's equally important. So thanks a lot for staying with us today, and see you next time.